Good afternoon. Are you able to hear me? Am I audible? Please reply me in the chat box. Mishak, am I audible? And is the board clear to you? Okay. Let's start from where we have left. Last we had seen was an equivalence relation, right? Now, one thing you guys try to understand that in your 11th standard, you have a chapter name as sets and relations, and again in 12th standard you have the chapter name as relations and functions. Now the problem is when we talk about JEE, they ask questions only on functions. Sets and relations questions used to come in once upon a time when the exams were used to be known as AIEEE. Okay, which got combined as JEE mains. So now in JEE mains, they don't ask you the questions on sets and relations. They ask you question only on the functions. And now the problem is, as per the procedure or the modules we are following, this relations and functions is going to come you only in the 12th standard. So high level questions which are of this chapter, sets, relations and functions, the high level or JEE questions will do only in 12th standard because I am going as per the module which the Perfect Academy has set. Okay, so here I cannot teach you some advanced numericals because again the same topic I have to teach you in 12th standard. So if I am teaching you now, what I will teach you in 12th standard? I have only given the base of this chapter in 12th standard, and all the basically numericals will be done in 12th standard when again we'll start the chapter and we'll go to the topic which is actually asking JEE itself. Okay, I cannot take some numericals because again I have to do in the 12th standard. But after this chapter, if we complete this chapter today, then we'll start with trigonometry. So now when we start with the trigonometry, there we are going to do JEE mains and JEE advanced numericals. Okay, for this chapter, sets and relations, okay, there are only AIEEE numericals, that also 2007, 2008 and 2002, which are not asked now. Okay, so let's start from where we had. So we had seen types of relations. Did we do the graphical method, that is the arrow diagram, in the last class? Please reply me in the chat box. Did I show you arrow diagram in the last class? Please reply me in the chat box. Did I show you arrow diagram in the last class? If not, then I'll do now. Okay, so let's see graphical representation. In the fifth also we have seen the graphical representation, and that graphical representation was called as Venn diagram. In this case, the graphical representation is called as an arrow diagram. Suppose I have the set A as 1, 2 and 3, and I have another set B as say A, comma B. And we know that when I find out the Cartesian product, so it will be 1, comma A, 2, comma A, 3, comma A, then 1, comma B, 2, comma B, and 3, comma B. We very well know that subset of the Cartesian product will be called as a relation. Let me consider one relation, one subset of this. So any subset will be called as a relation. So let me draw the sets A and B. This is my set A, this is my set B. Set A is having the element 1, 2 and 3. Set B is having elements A, comma B. Now what relation I've written over here is 1 comma A2 comma A2 comma B, which means 1 is run into A. So I'll draw a line from 1 to A and show the arrow from 1 to A. Because first I'm writing the elements of set A and then I'm writing the elements of set B. Hence the arrow will start from set A and go up till set B. Okay, 2 comma A. So from 2 I'll draw a line and show it towards A. Then 2 comma B. So I'll draw a line from 2 to B and I'll show the arrow from 2 to B. Okay, so we come to a very important thing over here, important concept over here. This are called as free images, whereas this are called as images. Okay, so set of free images is called as domain. Domain is nothing but set of free images, whereas set of images is called as range. Set of free images will be called as domain, whereas set of images will be called as range. Okay, and the entire set B in this case will be called as codomain. This entire set B will be called as codomain. And this is the arrow diagram. Why? Because we are showing the arrows, therefore this will be called as arrow diagram for relation R1. So I am considering one more set. A has 1, 2, 3, 4 and 5. Set B is A, B, C and D. And I am writing one more relation. Okay, R2 has 1A, 2B, 3C. I am writing another relation as A1, B2 and C3. Now let's draw the arrow diagram for this. So first I am going to draw the arrow diagram for R2. Now when I draw the arrow diagram for R2, so first I draw set A and then I draw set B. Set A in this case is an element 1, 2, 3, 4 and 5. Set B is having the elements A, B, C and D. Now when I plot relation R1, I have written 1 comma A. So I will draw a line between 1 and A. Then I have written 2 comma B. So I will connect 2 and B. Then I have written 3 comma C. So I will connect 3 and C. First I have written the elements of set A and then the elements of set B. Hence the arrow will be from A to B. So this is the relation from A to B. So this will be also called as the arrow diagram for relation R2. Now in this case, these three elements are free images, whereas these three elements are the images. So these are my images and these are called as free images. So we know that the set of free images now is called as domain. Therefore in this case, the domain will be which are free images, only 1, 2 and 3 free images. 4 and 5 is not related to any element. Therefore 4 and 5 are not free images. Therefore my domain will be 1, 2 and 3 in this case. Range. What is range? I have written. It is set of images. So which are images in this case? A, B and C. These are images. D is not an image. Therefore my domain in this case will be A, comma B, comma C. What will be codomain? The entire set B in this case will be called as codomain. The entire set B consists of A, B, C and D. So this entire set B will be called, so my codomain will be ABC. If I come over here, so what will be my domain in this case? For relation R1, my domain will be 1 and 2 because 3 is not having any image, it is not a free image, and range. In this case, A and B both are images, therefore A and B will be my range. Codomain is entire set B, and set B is also having only two elements A and B. So in this case, my codomain will be A comma B. Okay, so this is about from the graphical representation. It's easy to understand what is domain, range, and codomain. Therefore, I have showed you the graphical representation also, and I have showed you what is domain, what is range. Okay, domain is set of free images, range is set of images. Codomain is the entire set B. It need not be always set B. From where the arrows end, okay, where the arrows end, that set will be called as codomain. Okay, please take a screenshot of this, everyone. So we'll move to the relation R3. I hope everyone has taken the screenshot. So let's go for relation R3. So again I will write A and B. That A is having elements 1, 2, 3, 4 and 5. Set B is having elements A, B, C and D. Now if I see R3, A comma 1. So I'll draw a line from A to 1. Then B comma 2. So I'll draw a line from B to 2. Then C comma 3. So I'll draw a line from C to 3. But this time I have written elements B first and then set their elements of set A. Therefore, this time the arrow will be in this direction. So now where the arrows are ending this time, the arrows are ending at set A this time. Hence, this time my set A will be called as codomain. Hence, in this case, A, B, and C. From here the arrows emanate. This will be called as three images in this case. And this 1, 2 and 3, this will be called as images in this case. From where arrows emanate are three images and where the arrows end are images and the entire set is codomain. In this case, my domain will be A, comma B, comma C. My range will be set of images. In this case, it is 1 and 3. And my codomain will be entire set A. So my set A is 1, 2, 3, 4 and 5. The codomain is the entire set A in this case. Okay. So now if you observe, you will see one thing between relation 2 and relation 3. Here the domain was 1, 2, 3. Here the range has become 1, 2, 3. There the range was ABC. Here the domain has become ABC. And it was exactly opposite. Here the arrows were going from left to right. In this case, the arrows are going from right to left. So hence this R3 has been given special name and it is called as inverse relation. Denoted by R raised to -1, but you should not read it as R raised to -1. Okay, you should always read it as inverse. So this is inverse relation, my R3. So if my relation is from A to B, from C to B, which can also be denoted as A or B, then my R inverse will be in the reverse direction, that is from B to A. If my relation is from A to B, then my inverse will be from B to A, opposite. Similarly, if my relation is from B to A, then inverse will be from A to B. As simple as that. You just have to do the opposite. If it is A to B, then you have to do B to A. If it is B to A, then you should do A to B. Reverse is called as inverse. If you start doing the reverse thing, then it will be called as inverse. Okay? I hope you understood. So if you just see over here, domain has become range and range has become domain. Hence, for the inverse relation, we say that whenever a relation is an inverse relation, then my domain becomes range and my range becomes domain. Okay, so you have to remember this thing for inverse. Okay, the domain of the relation. Here, the domain of the relation was 1, 2, and 3, which became range. Here, the range of the relation was ABC, and in inverse, that range became domain AB. So, whenever you go from relation to inverse, okay, domain will become range and range will become domain. So, if you know domain and range of relation, you don't have to find out domain and range separately for inverse. Okay, for inverse, you just write domain as range and range as domain. Okay, vice versa. If you are knowing the range and domain for inverse, we don't have to find out it for a relation, which will just write range instead of domain and domain instead of range. Okay, so please take the screenshot of this. Don't take these things lightly, students, and don't think that there is only teaching fundamentals. The entire numericals will come in your GWE means exam. Okay, from the functions and okay, maximum questions which are asked on the functions will always be on range and domain. We will always be given the question to find out range and domain of a function. Understand it here clearly so that when we do JEE numericals, you will not face any problems or issues with that. Okay, though it may look a very simple topic, but the moment we start solving JEE means numerical, you will understand that it's not that easy. Okay, it seems to be easy, but we are starting with easy, seems to be easy part so that you can grab it properly. Okay, I hope everyone has taken the screenshot. Do understand this properly. Set of three images is domain and set of images is range. And the entire set B or the entire set where the arrows end, that entire set will be called as codomain. So today we have seen what is inverse relation. Also in the previous class we have seen what is reflexive relation, what is symmetric relation, what is transitive relation, what is identity relation, and what is an equivalence relation. So we are good to go. We will start with some numerical parts. Okay, we'll start with some numerical parts. So let's start. So I've been given that relation are 1, 1, 2, 2, 3, 3, 1, 2, 2, 3, and 1, 3. This is my relation R on set A. Set A is been given as 1, 2, and 3. So it is asking us, is this relation, it is reflexive and not symmetric? Option B is reflexive and not transitive. Option C is symmetric and transitive. And option D is neither symmetric nor transitive. So if we just remember the definitions on basis of that will be there is no hi-fi solution for this. So reflexive. So if it is reflexive, every element of the set should have relation with itself. Every element, okay, should have relation with itself. So in this case, the set is 1, 2 and 3. So every element of set A should have relation with itself. So when it has relation with itself, so essentially it should have all these three elements. So if it is having essentially all these three elements 1, 1, 2, 2, 3, 3, then it will be reflexive. So let's see if it is having yes 1, 1, 2, 2, 3, 3 is present. So the given is reflexive. So we know that the given relation is reflexive. Second, we'll check for symmetric. So how do we check for symmetric? If A is related to B, then B should be related to A for every element of the given relation. So 1, 1 reverse of 1, 1 will be 1, 1 present. 2, 2 reverse will be 2, 3. 3, 3 reverse will be 3, 3 and let is present. Now 1, 2 reverse of 1, 2. 1, 2 is my A to B. So its reverse should be 2, 1. Next element 2, 3. So 2, 3 is A to B. Then B to A should be 3, 2. Similarly 1, 3. If 1, 3 is A to B, then its reverse will be 3, 1. So this all the elements should be present in the given relation. So 1, 2 reverse that is 2, 1 should be present. 2, 3 reverse that is 3, 2 should be present. And reverse of 1, 3 that is 3, 1 should be present. So if we observe this are not present. 2, 1, 3, 2 and 3, 1 is not there in the given relation. Therefore, it is not symmetric. Therefore, a given relation is not symmetric. Now let's check for transitive. Now when we check for transitive, then we see the condition if A is related to B and if B is related to C, then only A should be related to C. It means the pairing should be there. So this we know that this is inherently transitive. This is an identity relation and we know every identity relation is symmetric, transitive and reflexive also. So we will only check for these three elements. Each and every element of the relation should be checked. So if I call this as A and if I call this as B, here also are two, so this is B and this is C. Then there should be relation between A and C. Okay, that is 1, 3 should be present, which is there. So this pairing is possible. So it looks transitive. Next, if I name this as A and name this as B. So this is my B, this is C. There is no pairing only. In this case, there is no pairing. If there is no pairing, okay, if there is no pairing, then you don't have to think about A and C. It is A to B and B to C. Here what I am getting is the opposite, C to B. You don't have to worry about the pairing, you don't have to worry about A and C. Why? Because you are not getting pairs. Pairs you will get if it is A, B and B, C. But here I am having A, B and C, B. So there is no pairs, you don't have to look for A, C. So this is also satisfying transition. Now let's look for this pair. If I name this as A and name this as B. So this will become my A and this will become my C. And then this will become my B. And this will become my C. Again, AB and CB. AB and BC should be there. Then we look for A and C. But here I am having AB and CB. So again, no pairs are there. If no pairs are there, you don't have to look for A, C. But one pair we got, and that was transitive. This is AB and this is BC. Then A, C, 1, 3 is present. So yes, it is transitive. So now let's see which of the option is getting satisfied from this. So a given relation R is reflexive and transitive, whereas it is not symmetric. So reflexive, not symmetric, reflexive, not transitive. No, we have got that it is reflexive as well as transitive. Symmetric and transitive. No, it is transitive, but it is not symmetric. Neither symmetric nor transitive. It is not symmetric, but it is transitive. So this option is also. So this is the right option. Okay. So our answer will be this given relation is reflexive, but it is not symmetric. Okay. So our answer will be option number A. So please take the screenshot of this. I'll just come in 2 minutes. Take the screenshot. I hope everyone is taking the screenshot. Next question in set A. 1, 2, 3, 4, and 5. A relation R is defined by R is a relation of x comma y such that x comma y belongs to set A and my x is less than 1. Then my relation R is reflexive, symmetric, transitive, or none of these. So first I have to write this in the list form, that is the roster form. Then only we'll get an idea about is it reflexive, symmetric, transitive, or not. Okay. So let's try to write it in the roster form. So we're saying that x comma y. So first we have to write x element and then we have to write the y element. And when we write the element, what things we should keep in our mind is that my x should be less than y. So the first element which I am writing should be less than the second element. So 1 is less than everyone, so I can write 1, 2, 1, 3, 1, 4, 1, 5. Then I can write 2 is less than 3 also, 2 is less than 4 also, 2 is less than 5 also. So this is getting satisfied. Next, 3 is less than 4 also, and 3 is less than 5 also. Similarly, 4 is less than 5. So now when I write this relation in the roster form, this is what I get. Now I check for if it is reflexive, symmetric, transitive or none. So when I talk about reflexive, every element of the set should be related to itself. So when I talk about this, I should have element 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Every element of the set should be related to itself. Which means this element should be there over here, then only it should be reflexive. But if we see, we are not getting any of these elements over here. All they should be present, which is not there. Hence, the given relation is not reflected. Next, we'll check for symmetric. So if it is, in this case, I'll write if x is related to y, then symmetric means y is related to x. The reverse should be present. So 1, 2, its reverse will be 2, 1. 1, 3, its reverse will be 3, 1. 1, 4, its reverse will be 4, 1. If you see, if I start writing none of the, all elements should have its reverse. So the moment you write 1 and 2 itself, you will understand if it is symmetric or not. So this elements 2, 1, 3, 1, if you see, it is not there. So this is not symmetric. Now let's see for transitive. When we talk for transitive, we will have to check all the pairs. If A is related to B and if B is related to C, then my A also should be related to C. But if and only if you are getting the pair, then only you will go for A and C. Otherwise, you will not go for A and C. Remember that. So first, if I take this as A and B, so here B means I will have to go for this. So this becomes my B, C. Then there should be relation between A and C, that is 1, 3 present. So first pairing is done. Then let's see for the second pairing. If I consider this as A, B, okay, and then 3. So 3 is here, B, C. If A is related to B and B is related to C, then 1, A, C, that is 1, 4. 1, 4 should be present. It's there. Yes. So this pair is also done. Then if I call it as A and call this is B, then I have here, B, C. So if A is related to B and B is related to C, then A also should be related to C. That is 1, 5 should be present. It's there. And this pairing is also done. Next, if I take this as A and this is B, then I don't have B, I don't have B, C. I have C, B. So this doesn't have any pair only. If it doesn't have any pair only, we'll not look for A, C. So this will also satisfy my transitive definition. Then I'll go for the next pair. Each and every pair you have to check. The transitive is the only complex one. Each and every element is there. For each and every element you have to check. If any one element also of the entire relation, this many elements are there. If any one element also of the relation, okay, is not satisfying this definition, then it will be, okay, called as non-transitive. Next 2, 3. So if I name this as A and B, so B, that is with 3. So this becomes my B, C. Okay, so here I am getting a pair A, B, B, C. Then there should be relation between A and C, that is 2, 4. Present? Yes, present. So this is also done. Next A, B. So then B, C. So this is my B, C. Okay. So A, B and A, C. So there should be relation between A and C, that is 2, 5. Is it there? Yes, 2, 5 is there. So this pair is also done. Now let's move to next pair A, B. So now 5 So here we have B comma, I have C comma B. I should have B comma C. But instead I have C comma B. So there is no pair for this. Since there is no pair for this, this is inherently transitive. Why? Because there is no pairing. If there is no pairing, you will not go for third condition. Only if these both conditions are satisfied, then only you look for third condition. Okay. Let's go for next. So this is A, B, then 4. So this is B and C. So if A comma B, then B comma C. Then A and C should be related. Means A and C. So here A 3 and C 5. So 3 comma 5 should be there. Present? Yes, present. So this is also transitive. Now next pair. This is A comma B. This is C. So I don't have A, B and B. I have A, B and C. So I don't have to look for A. No, and this also is not an unique pair, so this is also transitive. So yes, the given relation R is transitive. So what we understand that the given relation is not reflexive, not symmetric, but it is transitive. Yes. So my answer will be option number 2. Okay. This given relation is transitive. Please take the screenshot of this. Please take the screenshot of this. Done. I hope everyone has taken the screenshot. Let's go for next relation. R is a relation of A comma B such that A is sister of B and A comma B belongs to G, where G is a number set of girls. Now try to understand this. A is a sister of B. Now I have to find out is it reflexive, symmetric and transitive. So first reflection, every element should have relation with itself. In this case, relation with itself. So how will I write relation with itself? I'll write the same sentence, but I'll replace B with A. So A is sister of A. Is this true? Can I be brother of myself? No. You cannot be brother or sister of yourself. So A cannot be sister of A. What is a sister? If there are two children, okay, and if both have the same parents, and if one of them is a girl, then we call it as a sister. Right? So this is not true, hence not reflective. Then symmetric. So if A is sister of B, so this is A is related to B. So how do you write opposite? Opposite you will write, you replace B with A and A with B. So B is sister of A. Now if these both are true, then only it is symmetric. So A is a sister of B. What it indicates? A is a female. So B can be brother also, B can be male also and female also. Right? B can be male, B can be female also. But if you see, what is written over here is A and B both belongs to G, where G is girl, which means B is female in this case. Okay, why? Because A and B belong to G. This indicates that B is female. So A is the sister of B is also sister of A. That is true. Both are girls. And if it is girls, we don't call them as brothers, we call them as sisters only. So if A is the sister of B, then B is also sister of A. Right? Yes. It is symmetric. So in this case, it next transitive. So if A, how do you write transitive? A is sister of B, B is sister of C. Then A is sister of C. Now if this statement is satisfied, when I write A is sister of B means I am saying A is related to B. When I am writing B is sister of C, which means I am writing B is related to C. When I am writing A is sister of C, which means I am writing A is related to C. So we very well know that if this both is, then this condition should get satisfied, then only it is transitive. So A is the sister of B indicates A is female, B is the sister of C, that indicates B is also female. Okay? Now A is the sister of C. Now C can be male also and female also. In any case, if C is male or if C is female, it doesn't matter because A is a girl, A is female, right? Hence, A will be called the sister of C only. Even if C is a boy or C is a girl. Even if C is a boy or C is a girl, you are going to say A is sister only. So it doesn't matter, hence it is transitive. So this given relation, okay, this given relation is symmetric as well as given relation is transitive and the given relation is not reflexive. Okay, so if you remember when I started on the day one, I said that this mathematics is not only limited to the numbers. We can do more than numbers with this mathematics, and this example is taken for that only. Then there are a lot of different kinds of relations and webs of relations. We can use this techniques of relations, mathematics, and we can solve those webs. Everyone please take the screenshot of this. Please take the screenshot of this. Okay, I hope everyone has taken this screenshot. Now what I am doing is, I am but I am removing this condition. Last time I had said that A and B both belong to girls, but this time I am changing the condition. So now let's see what will happen. So reflexive, it is but of it's not reflexive. A is the sister of A. It is not studying psychology, we are studying math. In psychology, if you study then can be his own friend, own enemy, okay, his own brother, sister, own companion, everything. But we are not in psychology. We are in math where we deal with actual definition. Huh? So A cannot be sister of A, so it is not reflexive. Next now, here is the thing. So this time I am not saying B is a female. Last time I said A and B both belong to girls. But this time I am not saying this. So both possibilities are there. B can be male also, B can be female also. A should be female only. Then only A can be called as a sister. So A is that is perfect. But B can be male or female. So if B is male, then this becomes wrong. Then B is brother of A. If B is male or a boy, then we'll call B is the brother of A. B is not a sister of A. See, if the screen is not clear, then there will be an internet problem from my side or your side. Now I cannot leave the lecture and go and see the laptop of the internet is not working properly. To concentrate on moment internet becomes stable, the screen will also be clear to you guys. Just concentrate on my words right now. If the board is not clear, okay. Now B can be male or B can be female. If it is a female, then this sentence is right. B is the sister of A. But if B is a male, then I cannot say B is the sister of A. Then what I will have to say, B is the brother of A. B is not sister because B is male. So B can be brother, B cannot be sister. Hence, now this sentence is not going to work. This sentence is not true. Okay, for male. Hence, this time this relation becomes not symmetric. For transitive, we have already seen if A is the sister of B and B is the sister of A, that definitely means A and B have to be female. And then A is sister of female. She is male or female, it doesn't matter. Okay, if A is a girl, then she will be sister only. She cannot be brother. Okay, so it is transitive, but this time it is not symmetric. Last time due to that condition, the relation became symmetric. This time when I remove the condition that A and B is girl, so what happened? Now the same relation that A is the sister of B, now that relation became not symmetric. Okay, everyone take the screenshot. Okay, I hope everyone's taken screenshot. Let's move to next type of questions. Next set of questions. So R is a relation defined in A such that R is a relation of A to B such that mod of A square minus B square is less than or equals to 5. And where set A is 1, 2, and 3. R is defined on set A. Which of the following is false? Which of the following is false? Okay, A is R 1, 2, 2, 2, 3, 3, 2, 1, 2, 3, and 3, 2. Option B. Option B is codomain of R is 1, 2, and 3. Option number C is domain of R is 1, 2, and 3. Domain is 1, 2, and 3. And option D is range is 1, 2, and 3. So first of all, let's check the option A because we have written a relation and the condition is given for the relation. And the condition is when you do A square minus B square, it should be less than 5. So it is relation of A comma B. So all the first elements are A and all the next elements are B. All the first elements are A, next all the other elements are B. So now let's if I take 3 square minus 2 square, so that is 9 minus 4, that is 5. So it is satisfying the condition. Now when I do this, this also will give me 4, 2 square minus 3 square, so that is 4 minus 9. So that is again 5, which is again satisfying the condition. Now I do 2 minus 1. So 2 square minus 1 square. So 4 minus 1 is 3. So satisfying. Here 9 minus 9. Okay, that is 0. Satisfying. 2 minus 2, 0, satisfying. 1 minus 2, this is satisfying. So this is true. It is true. Next, codomain. If you see the relation, the given relation can be, and if it is not set A, the given relation can only be obtained if I do, okay, combination product of A with A. Okay, so it is possible. So one set, the set B is called as codomain. So this is also true. This is also true. Okay. Now either of this one has to be false. So domain are all the first elements and range are all the second elements. 1, 2 and 3. Domain is also 1, 2 and 3 and range 1, 2 and 3. A square minus B square. 9 square, sorry, 3 square, that is 9. Any other condition? Mod of A minus B square. Sorry, there is one mistake over here. It is not equal to, it is less than. Okay, if we see domain is also 1, 2 and 3, all the first elements. Okay, all the first elements will be called as domain. The first element 1, 2 and 3, and set of the second elements will be called as range. Here are there 2, 3, yeah, 1, 2, 3, so range is also right, 1, 2 and 3. Okay, it was not equal to, it was less than 5. If I see over here, I'm getting that if I am not getting less than 5. So this 3, 2 and 2 is satisfying. Elements are not satisfying this given condition. So it was not less than or equal to, it was only less than 5. So if I do 3 square minus 2 square, so that is 9 minus 4, so that is 5. 5 is not less than 5. So this is my answer. So which is false? Option number A. Okay. So for a given relation, which of the statement is false? So option A is false. Take the screenshot. Next, a relation R is defined by R1 is the relation of A comma B such that A is greater than or equal to B and A comma B belongs to real number. Then R1 is option number A, equivalence relation. Option number B, reflexive, transitive, but not symmetric. Option number C, symmetric and transitive, but not reflexive. Option number D, neither transitive nor reflexive. Neither transitive nor reflexive, but symmetric. Okay? And give me the answer in chat box. I'm waiting. Take 1 minute, okay, and reply me in the chat box option A, B, C, or D, which is right answer. If R1 is the relation from A to B such that A is greater than B, and A and B both belong to real numbers, then which of the following options is true? A, B, C and D. Reply me in the chat box. Give me the answer in chat box. Just write the option number A, B, C or D. Reply me in the chat. If you reply me in the chat box, that means you are understanding. If you are not replying in the chat box, it means you are not understanding anything. Give me the answer. A, B, C, D. Just type A, B, C, D and send it in the chat box. Why no answers? Why haven't you guys given any answers up till now? A, B, C, D, any option, which option, just reply me. You guys are not at all attentive in the class. Each and everyone has to come late every time. They have to remain absent in the class. This time I am seeing one or two new students. Others, the last time are not present this time. And then you want me to be okay ahead or with your class school syllabus. How you tell me? So first thing is you just concentrate on this condition. A is greater than B. My relation from A to B says that my A should be greater than B. So my B to A relation, which means I simply have to, instead of A, write B, and instead of B, write A. Okay. So if you see over here, this is the condition for something to be symmetric. And we very well know that if A is greater than B, then B cannot be greater than A. So it is 101% not symmetric. So it is 101% not equivalent, because for an equivalence relation it has to be okay reflexive, transitive and symmetric. It is 101% not symmetric, because this can never get satisfied. If A is greater than B, then B cannot be greater than A. 101%. Right? So this cannot be symmetric. So this option A and option B is gone. Now either the answer is option number C, or either the option is no, neither, but symmetric. This is also not there. He's saying that it is symmetric. It can never be symmetric. So here we don't even have to prove a little bit what is saying not symmetric. This is true. B is true, sorry. This is saying symmetric, it cannot be symmetric. This is saying symmetric, it cannot be symmetric. So but obviously, sorry, answer is option number B. It is not symmetric. We very well know that. It is not symmetric. There is only one option in the entire A, B, C, D, which is saying that it is not symmetric. So we don't even need to check for reflexive and transitive. Either of the four options can only be correct. And we very well know that it is not symmetric. That's 101% is option number B. So many times, okay, you don't need to solve the entire one. We can also apply this procedure. Cancel all the options which are not possible. So one option is only remaining, that is the answer. We don't have to think about solving. Now why this is required? Because if you have to solve 30 questions in your exam, you have only 2.5 minutes per question. You will not get more than 2.5 minutes to solve one question. But it's not that every time we'll be able to solve each and every numerical in 2.5 minutes. Sometimes we'll be able to solve early, sometimes we'll take 5 minutes or 7 minutes to solve the numerical. So in that case, how will we cope up? So this is the methodology. Okay, I just took the condition and I just checked for symmetricity, and I directly got it option D. Since I'm teaching you as per experience, that is why it is taking time. But if you know this concept already, it will not even take 30 seconds to get to the right answer. So if you are not even taking 30 seconds, so what happened with you is you saved 2 minutes, which can be utilized for another question. So suppose in one question you took 5 minutes, so 2.5 minutes you have already taken of one of the questions. So somehow you have to recover the 2.5 minutes. So this is how you can recover 2 minutes from here. And not here many numericals will see where we can apply this methodology. Okay. So this is also one method, cancel out the wrong one. So everyone take the screenshot of this fast. Okay. Let's see next set of numericals. If R is a relation defined by x comma y such that x comma y belongs to natural numbers and 2x plus y is equal to 41. 2x plus y is 41. Then R is option A reflexive, option B symmetric, option C transitive, option D none of these. So again we'll go for the cancellation method only. For reflexive means same element you have to take. So suppose if I take x is equal to 1, then I will have to take y also is equal to 1. Okay, and natural numbers, which means I have to start from 1. So it is 101%, it is not going to satisfy. Why? Because 2x plus y should be equal to 41. So x and y will never be equal, so it is 101% not reflexive. Similarly, suppose if I take x is equal to 1 over there, then I'll get 2 plus y is equal to 41, which means I'll get y is equal to 39 when I took x is equal to 1. So now when it is symmetric, so if x is related to y, then y also should be related to x. So the same equation now, if this equation is 2x plus y is equal to 41, so for symmetric, wherever there is x, replace x with y, y with x. So this will become 2y plus x is equal to 41. So now if I replace this value, if I put y is equal to, this will become 2 into 39 plus 1. Will it give me 41? No. So 101% it is not symmetric also. 101% it is not symmetric also. Okay. Then you have to go for transitive. If 2x plus y is equal to 41, and 2y plus z is equal to 41, then 2x plus z should be also equal to 41. This is A to B, this is B to C, and this is A to C. Now you can very well understand it is not the same, because my x is double of y. So if y is satisfying the equation, then x is greater than y. Hence, this value will give me greater than 41 and not 41, which means it is not transitive also. So answer is none in this case, none of this. In this case, my answer is none of this. Okay, take the screenshot. I hope everyone has taken the screenshot. Okay. Let's go for next. See students, this relation doesn't come for GEE means exam. It used to come once upon a time when the exam was AIEEE. And now it is GEE means there is no AIEEE exam. So relations and sets, this chapter doesn't come in your exam. Therefore, I cannot bring very high-fi numericals for this two chapters. Next chapter it will start trigonometry. At that time, yes, we'll do a lot of means and advanced numericals because it is asked. Next, if L denotes all the straight lines in a plane, set L denotes straight lines in a plane. Let R be the relation defined by R is the relation defined as alpha comma beta such that alpha is perpendicular to beta and alpha comma beta belongs to lines. So this relation R is reflexive, symmetric, transitive, none of this. Think and give me the answer as A, B, C, D. Give me the answer as A, B, C, D. Which is the answer? Please, students, reply me in the chat box. Alpha is perpendicular to beta. So let's check. There is one line which I am naming it as alpha. There is another line which I am naming as beta. So yes, I can say that my alpha is perpendicular to beta. Now first for reflexive. So whenever you want to check for reflexive, you have to replace it by same. Alpha is perpendicular to alpha. Is it true? No. A line cannot be perpendicular to itself. A line can coincide with itself. Or line, in other words, makes zero angle with itself. So you can say a line can be parallel to itself. But you cannot say that a line can be perpendicular to itself. So yes, it is not reflexive. So this is false. Now for symmetric. So if alpha is perpendicular to beta, then beta should also be perpendicular to alpha. So yes, this is true. If alpha line is perpendicular to beta, you can write the inverse also. Beta is perpendicular to alpha. Both are true. So this is true. Therefore symmetric. If alpha is perpendicular to beta, and if say beta is perpendicular to gamma, this is my beta, and it is perpendicular to one more line gamma, then my alpha should be perpendicular to gamma. This is for transitive. A is related to B, B is related to C, then A should be related to C. But if you see, gamma and alpha are not perpendicular. You can easily see, instead both are parallel to each other. Then does this satisfy? No, this is not satisfying. When I write for transitive, it means if alpha is perpendicular to beta and if beta is perpendicular to gamma, then A should be related to T. That is, my alpha should be perpendicular to gamma. But we very well see that it is not true. It is false. My alpha is not perpendicular to gamma. This is false. Hence, it is not transitive. So it is symmetric. So answer is my option number B. Okay, that two lines are perpendicular. Two lines are perpendicular to itself. This relation is a symmetric relation. Okay. Now I'm keeping it same. I'm just changing the options. And I'm saying over here alpha is parallel to beta. Now tell me, now you tell me which option, A, B, C, D. Now this should not take time, this is simple. For reflexive, I write alpha is parallel to alpha. A line can be parallel to itself, I can say that. So symmetric. If alpha is parallel to beta, then beta also should be parallel to alpha. This is true. So this is also true. This is also true. It's transitive. If alpha is parallel to beta and beta is parallel to gamma, then alpha is parallel to gamma. Yes, this is my line alpha. This is my line beta. Both are parallel to each other. And line beta is parallel to line gamma. So I can say that my alpha is parallel to line gamma. This is also true. So my answer in this case will be an equivalence relation. So, okay, parallel lines denote equivalence relation, whereas perpendicular line denotes only symmetric relation. Okay, please take the screenshot of this. Please take a screenshot of this. Okay. Hope you must have taken screenshot of this. Let's move to next question. So today we are going to complete this chapter. So in the next class, we'll start with the next chapter called as trigonometry. Okay. Let's R is the relation of x comma y. That x is a cousin of y. Now this R is okay. Think and tell me reflective, symmetric, transitive. This reflective, not symmetric, not transitive. It is not reflective, symmetric, and not transitive. And D none of this. Think properly and give me an answer. X is a cousin of Y. Think properly and tell me. Okay, X is a cousin of Y. This relation is Okay, reflexive, symmetric, transitive, option A, B, C, D. Take a minute for think and reply me in the chat box. A, B, C, D. Which option? Done. What is the answer? A, B, C, D. So first you have to check for reflexive. So when you check for reflexive, I'll have to write X is the cousin of A. So X is the cousin of X only. So I can be cousin of myself. Okay, so this is false. Hence not reflexive. Next, symmetric. If I'm saying X is cousin of Y, then it's opposite or reverse. Y is cousin of X. True, right? You say X is cousin of Y, or you say Y is cousin of X. Reply me in the chat box. Are you able to hear me? Am I audible? Students, am I audible? Is the board clear? Okay. So yes, if I say X is cousin of Y or Y is cousin of X, it is one and the same. It doesn't matter. Okay, X is the cousin of Y or Y is the cousin of X. It's true. So yes, it is symmetric. Now third, let's check for transitive. So transitive says that if X is cousin of Y and if Y is cousin of Z, then X is cousin of Z. Think and tell me if it is true or false. Be very careful in this. It is the word cousin. Now try to understand. Cousin from can be from maternal side or it can be from paternal side. That is from the mother's side or from the father's side. Right? So mothers, sisters, children, those will be your cousins. And okay, my father's brother's children, those will also be my cousins. So this A is related to B and B is related to C. But it did not be always A is related to C, right? My mother can be from Gujarat. Okay, my father can be from okay Tamil Nadu. Hence, it's not that both may be relative of each other. They must have got married, and I was born. So from my father's side also there will be some relatives which will become my cousin. From mother's side also there will be some relatives which will become my cousin. But this both need not be cousins. Huh? Hence, this is non-transitive. Okay? X is cousin of Y. I am Y. There is X which is my cousin. There is Z which is my cousin. But A and Z, okay, will be cousins. That is not true. So this is not true. This is also false. So this given relation is only symmetric. It is neither reflexive, neither transitive. So do we have this option? It is not this. Reflective, it is not reflexive, not transitive, but symmetric. Yes. So my answer is option number C. Take the screenshot fast. We'll go for next question. Take the screenshot fast. Okay. I hope everyone has taken the screenshot. Let's move for the next question. Last question of the chapter, and then we'll start with trigonometry. So let R be the relation defined as R is the relation of x comma y such that y is equals to mod of x minus 1, where x belongs to integers. Z here stands for integers, and mod of x is less than or equals to 3. So option A, relation R is 1 comma 0, 1 comma 2, 3 comma 2, 4 comma 3. Option B, minus 3 comma 4, minus 2 comma 3, minus 1 comma 2, 0 comma 1, 1 comma 0, 2 comma 1, 3 comma 2. Option number C, 4 minus 3, 3 minus 2, 2 minus 1, 1 comma 0, 2 comma 3. Option number D, none. Okay, so if you look at this problem, the condition what is given us, my y should be x minus 1, and at the same time my x cannot be greater than 3. So if I have a number which is not greater than 3, so and which belongs to integers also, okay, it should not, my mod of x, so it should be less than plus minus 3. So if I do 1 minus 1, I can do 0 minus 1, I can do minus 1 minus 1, minus 2 minus 1, minus 3 minus 1. Similarly here I can do 2 minus 1, or I can do 3 minus 1. So this is going to give me 2, 1, 0, 1, it is mod, so it is not going to give any negative answer. This is 2, this is 3, and this has the potential to give me 4. So let's write the relation to x comma y. So here I've taken x as 3 and I've got y as 2. So this gives me 3 comma 2. Here I've taken x as 2 and I've got y as 1. So this is 2 comma 1. Here I've taken x as 1, I've got y as 0. So this is 1 comma 0. This is 0 comma 1. -1 2, -2 3, -3 4. Okay, so see which of the option is satisfying this. So if you see B, yes, option number B is satisfying this. 3 2 is there, 2 1 is there, 1 0 is there, 0 1 is there, -1 2 is there, -2 3 is there, -3 4 is there. Yes. So my answer is option number B. Next, in the same question is saying domain is, in the same question. So we have got my answer is option number B. In the same question is asking domain of this is, domain is option A 0 1 2 3 4, option B 1 3 4, option C -3 -2 -1 0 1 2 and 3, and option D 0 1 2 3 4. So domain. What is domain? All the first elements will be called as domain. So this is the answer. So this, all these numbers, these first letters are domain. So if I make a set of all these numbers will give me, or these values will give me domain. So my domain should have all these numbers 0, 1, 2, 3 and -1, 2, 3. So yes, it's there. So option C is my answer. Okay, option C is my answer. Next, range is, in the same question is asked three different questions. Range is option A 0, 1, 2, 3, 4. Option B -3, -2, -1, 0, 1, 2, 3. Option C -4, -3, -1, -2, 0. Option number D -1, 0, 1, 2, 3 and 4. So range. All the second elements will be called as range. So this 4, 3, 2, 1, 0, 1, 2. So do I have this? So all positive numbers are only there. 0, 1, 2, 3 and 4. 0, 1, 2, 3, 4. Okay, in set one element can be written only once. 0, 1, 2, 1 is already taken, 2 is already taken, 3 and 4. So it is 0, 1, 2, 3, 4. So here my answer is option number A. So the range, okay, range is 0, 1, 2, 3, 4. I hope everyone has understood. Okay, please take the screenshot of this. Please take the screenshot of this. Taken screenshot. Okay, so here our chapter relation gets over, and the next class we are going to start with trigonometry. Okay, and I'll hope that you guys are already well prepared with what you have done already in your 10th standard. So I don't have to waste my time in the fundamentals. Okay, I'll give you one technique to remember the formula, and I'll give you some formulae which you have to remember, and then we'll directly start with the JEE mains and advanced numericals. Okay. So have a nice day ahead.
Thank you, sir.